Good morning, students. Am I audible?
Morning, sir.
Good morning. Okay, inform your friend quickly, okay, to join. So this is your class of Railway Engineering, Professional Elective 1. Inform all, okay, to join. Okay, anyone else coming? If no one coming, then I will start. Okay, we're going to start now, okay? So you can consider this is your last class of your second module, fine? So in the last class, in the very previous class, we have discussed about different wear of rails, right? If you remember. Okay. So in this class, we're going to discuss about one kind of drawback, or you can say that error. You can say that it must be removed time to time from the railway track for smooth movement of the rail. Okay. And that particular error is called creep. 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 Okay. So we are going to discuss about creep of rail. So we're going to discuss about what is creep, how creep occur, and how to um, remove the effect of creep. Clear? So let me allow my screen to come. My screen is visible, is it?
Yes, sir.
Okay. So here you can see the topic name is given here, creep of rail. We're going to discuss about what is creep, And what is the cause of creep? What is the effect of creep on the railway movement? And what are the remedies? Okay, like that. Not gods actually. It should be removed. We already discussed about gods, right? Okay. So basically, what is creep? Creep is what? It is defined as the longitudinal movement of the rail with respect to sleeper. Okay. So basically, what is creep? It's very simple definition. Creep is defined as the longitudinal movement of rails with respect to sleeper. Now, what does this mean actually? And why rail move forward with respect to sleeper? That we are going to discuss. And what are the effect of that movement of rail in forward or backward direction? Okay. Now, this creep is defined as the longitudinal movement of the rail with respect to the sleeper. This means what? I'm going to show you now. As per this definition, I'm going now you can see the top view of the rail. Okay, I'm showing you the top view. Okay, from top you can see this is your rail, isn't it? And sleeper is like that. Generally, it is called what? Rail patri, right? In Hindi, this is your patri, or you can say it's a railway track. It's a combination of rail and sleeper, right? Suppose this is a one rail, this is another rail, and it is joined by fishing plate like that, isn't it? You know this thing, right? Even the sleeper is joined with the ballast, okay, like with screw and key like that. Each sleeper is fixed with the ballast, fine, and the rail is fixed with sleeper with the fishing fastener, okay, and two rails are joined with your fishing plate. These things, I think it is clear to you. If you still have some confusion about fastening, you can also go about the revision, okay, go through the notes or go through your Google also, or even the textbooks. You find out the different fastener, okay, like fishing plate is a fastener to use to join two rail, okay, then key or spring used to join your slipper with ballast, fine, then there's a fastener to join rail with slipper, all these things, fine, they are all connected to each other. Now what is creep actually? Creep is defined as the longitudinal movement of the rail. That means this particular rail can move in this direction and also can move in this direction. Okay, due to different reason, maybe because of the poor maintenance of the track or because of the any other reason. We're going to discuss about the effect reason behind why creep is occur. But still, what is creep? First, understand this. Okay, creep is what actually? The longitudinal movement of the rail. That means longitudinal means this direction. Okay, along the movement of the train, there is a in a very small rate, a train moves in forward or forward direction of the railway movement. Okay, this is called creep. And why it is considered as a drawback? Okay, now suppose I just giving us example. Suppose this rail part, it moves in this direction. If this part rail in this direction, what will happen? The new position of the rail, suppose this rail, okay, in the same position, I'm drawing here only with a okay, wait, I'm drawing with a different color, wait, okay, same rail will be moved from like this. Suppose initially was from here to here, here to here. Now because of the creep, this rail move in this direction. Even suppose this one also move in this direction. Now because of that, what happened? The expansion gap between the initial expansion gap, standard expansion gap between the two rail, adjacent rail, increases. This much increases. Okay, and it will cause inconvenience for the movement of the rail. and when the rail move this direction, suppose, but slipper will not move in this with along with the rail. Slipper will be in the same position. Then what will happen? This part rail become unattached with slipper because slipper is here only, na? It is the last point of the slipper. Got it? चला गया. Wait, let me draw again. Aha. Let me draw a straight line. It is not exactly straight, but um, okay. So suppose initially the railway line is like that. Okay, this is your slipper. Fine. Suppose they are slipper like that. Okay. Now suppose due to the region, any other region, the rail line moves in this direction. That means, suppose the rail moves up to this point. This rail suppose move up to this point. It may be irregular. Okay. Then what will happen? If this rail move to this rail, eh, it's very difficult to draw these things. Okay, okay. Suppose they are these are your slipper. Okay, fine. Now due to creep, this this rail is come up to this point, and this rail suppose come up to this point. Now just shift this. Okay, if I move this up to this, and and if I move, let's see, can I do? Okay, anyway, so due to creep, what happened? This rail moved forward to this point. Okay, now what happened? You can see the sleeper. This part it become useless because it's not connected to the rail, and here there is no sleeper. Okay, so it caused very difficult position for rail movement. Okay, that's why we have to go from time to time maintenance of the railway track, and we have to check whether the creep is not cross the accessible limit or not. Creep, one more thing you have to understand, the creep will always going to happen, but we have to maintain the creep. Okay, anyway, do you have any idea, at least something you have got the idea, right? What is creep? Yes or no? So basically creep is what? Creep is defined as the longitudinal movement of the rail with respect to the sleeper. Okay, the rail have a tendency to gradually move in the direction of the dominant traffic. That means, suppose in a particular railway line, whether it is a one-way track or two-way track, it's depend on in which direction train moves regularly. Okay, so depending on the dominant traffic or depending on the dominant traffic direction, the rail have a tendency to move in that particular direction. Okay, and creep is going to happen in that direction only. It along the direction of dominant traffic. Clear? A creep is common to all railway track, and but its magnitude varies considerably from place to place. That means it is not a fixed amount of creep can be happen in a all kind of track. It's depend on the track gauge. Okay, depend on the gauge, depend on the geographical area, depending on the dominant traffic. All these things is depend on creep. Okay, creep is depend on different factors. Fine. So creep is common to all railway track, but its magnitude varies considerably from place to place. And the rail may move by several centimeter in month at a few places. That means we can this there is a standard limit. That means how much a rail can displace in a month. Okay, there is standard standards value is there as per Indian standard as per IS code. Okay, while at other location the momentum may be almost negligible. In some place it is very minor, and in another place it may be very huge. So depending on the geographical situation, depending on the traffic volume, or you can say depending on the track costs, the value of creep may vary. Okay, so this is all about what is creep actually, basically. Fine. So let's discuss what is the cost of creep base. Okay. So cost of creep, the main factor responsible for development of creep are as follows: ironing effect of wheel, starting and stopping operation, changing in temperature, unbalanced traffic, okay, poor maintenance of track. Okay, so basically, what is ironing effect of wheel means what? Uh, Actually, it and each wheel of the train creates a wave, kind of a um, wave pattern in the rail surface. Okay, wave pattern like we cannot see from a naked eye, but for it's kind of theoretical one. Okay, I'm showing you. I'm showing you a side view. Okay, this is your suppose rail. I'm showing you a side view like that. Suppose your train is moving. This is your train. Okay, this is suppose this is your train. I'm showing in this direction. Okay, again I'm drawing. Suppose this is uh your railway wheel. Okay, and due to the movement of the wheel on the rail surface, it creates a wave action. Okay, at any particular instant of time, the wave action can be understood by this. Okay, so whenever wheel move along the rail, it creates this kind of wave along the rail. Okay, like that. Okay, that means well, this wheel is moving in this is moving along in this direction. That means it's move forward, and because of the movement of this wheel, um, this wave action of the wheel, it tends to move the rail in forward direction. Got it? Okay. This is actually
Sir,
irony action of the wheel. Yeah,
sir, what is creating this wave? This is the force of the wheel.
it is not. Yeah, you can say the force of the wheel, or it's also depend on the weight of the wheel also, or weight coming on the wheel. Okay, you know all the train load is coming on the your wheel only, right? From wheel it go to slipper. Okay, so it is just a theory. Sorry, it is only a theory. Okay, I'm showing you in detail only. Just a second. So basically, what is creep here? You can see a creep is defined as a longitudinal movement of the rail with respect to slipper in track, and it is common in all railway track, but varies in considerably. The rail in some places moves by several centimeters in month, while in other locations the movement of the rail may be negligible. It is observed that the rail have a tendency to move forward move gradually in the direction of the dominant traffic. Okay, so basically this is the diagram. I'll show you the wave theory. Before that, here you can see the occurrence of creep can be noticed from the following observation. How can you say the creep is occurring in a particular railway track? Now, here you can see initially this is a joint of the rail, two rail. This is a trailing end of the rail. This is a leading end of one another rail. Okay, maybe there is a small expansion joint, maybe there, but now we can see because of the creep, this particular this particular rail, I'll show you. This particular rail move in this direction, and the gap get increases. Even the fishing plate, it is not. It is come out of the system, and you can see here. You can see the even the hole. Okay, here you can see the hole. The screw and hole come out of the plate, base plate, which can attach the rail with the slipper. Okay, so this is the actual you can see in the field only. So by using seeing only, you can see their creep is occurring. So how can you identify whether creep is occurring or not? Closing of successive expansion space at rail joint in the direction of the creep and opening out of the joint at the point where the creep start. That means you are seeing the last end of this rail. Suppose, if this rail move forward from this point, the expansion joint get increased. Now, if I consider this direction, that means I will show you here. If I consider, suppose if I draw again, extend this rail like that, here also some rail will be there. Okay, if this rail move in this direction, then that means what will happen? This move in this direction, it closen to that successive rail, and the gap between it will increase in at one end, and another wind the gap will decrease because it's shifted. Okay, so closing of successive expansion. Closing means here it is a closing, and expansion here you can see the expansion of rail joint. Fine. So by seeing this, you can see there is a creep is occurring. Okay, the marks on flanks and waves of rail made by spike head or by scraping of scratching as the rail side. That means we already discussed about different wear and tear action of the rail. Okay, so by seeing the wear and tear of the rail part also, we can understand that stress is uneven and there is a chance of you creep. Okay, now we can even here, even the drawing also you can see some scratch marks. You can see the side of the rail. Okay, so from there also you can see you can identify uh, there is a possibility of creep. Fine. So basically, uh, the creep is understood by different theories. Okay, so various theories are proposed to explain the different causes of creep, but none of them gives the true picture for real cause. Okay, that means there are still research going on for to find out exact you know proper way of why is creeping, how to derive or how to explain creep. But anyway, there is some theory, so we're going to discuss about that theory part. Okay, the various theory that for creep, the occurring of creep are like wave action or wave theory. Okay, then percussion theory, then drag theory, starting, accelerating, slowing down, or stopping of a train theory. Okay, then expansion or contraction of rail due to temperature or unbalanced traffic. These are the, you can say these are the um, theories, or you can say these are the cause. Basically, these are the cause because of which creep occur along the railway track. Okay. Now, about wave theory, we have already discussed. Anyway, we're going to discuss again. Okay, wait. Here you can see wave action. Now, I have already show you this wheel action, right? Now, suppose this wheel is now resting on the particular railway track. Okay, because of the load coming on this particular wheel, individual wheel, it gives some depression to the rail when it moves. Even if you look closely when rail move along the rail, did you observe that the rail part settles in the ground because of the impact, dynamic impact? It's moved upward and downward direction. Did you experience this kind of thing from the railway track? Even when train moves along a railway track, the nearby area get little bit shaken up. I think everyone have experienced this thing, right? So this is called a wave action. Okay, because of the movement of the wheel along the rail, it creates a wave action along the railway track. Okay, it's also depend on the speed of the rail. It's also depend on the weight of the or weight coming on the wheel. All these things. Fine. So we are not going in the very detailed mechanism of that, but to understand the creep, we are giving this. Okay. So anyway, because of this wave action, it somehow it try to push the rail in forward direction. Okay. So wave action is set up by moving loads or wheel. The vertical reverse curve, this reverse curve, you can say this upward, it is reverse curve. Suppose, the vertical reverse curve is formed in the rail ahead of the wheels, resulting from the rail deflection under the load, and it is the chief cause of or the prime cause of creep. The wheel push the wave with a tendency to force the rail in direction of the traffic. on a particular rail, the joint action by several wheels cause creep. As the wheel moves, the lift in front of the moving load is thus carried forward by the wheel and cause creep, whereas the lift at the near of the wheel gets back to its normal position. So I think these things already discussed with you that if you look closely when train move along a railway track, you can observe the rail part it move upward and downward direction. Okay, because of this wave action, and it tends to move the rail in forward direction. Okay, so you can say this is a kind of a prime cause of creep occur. Okay, so this is all about wave action of creep. Next, let's discuss about the percussion theory. Fine. So what is percussion theory basically? No need to go through it in big detail. So it's basically occur in case of joint. Now here you can see, suppose your rail is moving in this direction, okay, in right hand direction, and suppose this is your wheel of train, okay, and this is your rail part. This is your suppose trailing rail. This is your facing rail. That means or leading rail, you can say. Okay, so since your rail is moving in this direction, okay. Now at the instant when the wheel uh, touch the joint part, and this is your fishing plate connecting the two rail to each other. Fine. At the joint part, what happened? At the joint, because of the given expansion joint, at this part, the load is directly go to the down. I already told you that joint part is the weaker part in railway track. Okay, this joint part is the weaker part in railway track, and also I told you the sleepers are more given here near the joint. That means the sleeper spacing are very less in slipper spacing are less. That means more numbers of slippers are there nearby the joint part, because this joint area is little bit comparatively weaker part. Okay, now when the wheel come in the expansion part or joint part, you can see the resultant component of the weight or resultant component of the vertical load coming from the wheel in this direction. So you can see, and because of the this component of weight, there is a force will come, a resultant force will come in this direction. That means this at this joint, the moment of the wheel tends to move the facing rail or leading rail in this direction, and tends to move the trailing rail in this direction, like that. Or you can say, in other words, you can say, um, with respect to the trailing rail, with respect to trailing rail, the train or the rail moves forward. That means the facing rail or leading rail moves in forward direction from the joint part, okay, with respect to the sleeper and with respect to trailing rate. Okay, and this is explained by this percussion theory. Okay, this theory state that the creep is due to the impact of wheel at the rail end ahead of the joint. That means ahead of the joint when it just come to the joint part. Okay, from here also you can see I already explained this is a resultant component of the loads, and because of this resultant component of the load, a force will applied in this direction, which tends to move the rail in forward direction. These things clear. So this is all about your um, percussion theory. Fine. Next, another theory you can say this is your drag and dragging theory. Okay, so drag and dragging theory, it's similar to that first theory. It's your wave action. It is kind of similar. Okay, but drag and dragging theory basically it define what it's come from this concept that a train part as a whole train part is consists of two main component. One is your wagon part, another part is your engine. Suppose this is your engine or locomotive, you can say. Okay, and even the locomotive have a driving wheel. Okay, and other all are your what leading wheel, sorry, trailing wheel, right? So no any energy will connected to this wheel, they are only following the driving wheel of the locomotive only. Okay, so driving main the main power these driving wheel are considered as a powered wheel and other are unpowered wheel. Fine. So if I go to that first, that wave theory, the creep due to wave theory, it's for all the wheel. Fine. But the drag theory basically for your driving wheel. Okay, because this driving wheel, because of the engine power, it tends to move in forward direction. Fine. It tends to move in forward direction, but it also have to experience a drag force of this, the compartment which is connected to with the engine or with the locomotive. Okay, because of the um, wheel connected to different compartment or different wagon, this driving wheel experience a drag. Okay, which try to pull back. Because of this pulling up, pulling back phenomena, it's called dragging action, and because of that, your creep may occur. Okay, it is kind of similar to the wave action, but little bit different. Okay, so as per drag theory, it states that the backward thrust on driving wheel of the locomotive of train has got a tendency to push the rail of the track backward, while the other wheel of the locomotive and the wheels push the rail in direction of the travel, as explained in the wave theory. That means, as per wave theory, all wheels experience the wave action. Okay, but when it comes to drag theory, it's basically it's concentrate on the driving wheel only. So because of the uh, numbers of wheel connected to the leading, connected to the trailing wheels, which is actually of the wagon or passenger compartment or anything you can say. Okay, they, because of that a drag force occur in the driving wheel, and because of that your front or the leading rail part move in forward direction with respect to your trailing rail. Okay, so these all are theories only. Fine. So another other is a cause, you can say cause of creep are what? Starting, accelerating, or slowing down, or stopping a rail. Even you can understand from this point of view that suppose this is your rail line. Okay, this is a rail. This is a wheel. Suppose this is in a raised position. This is in a raised position. Okay. Now I already told you that rail start suddenly. It give a sudden acceleration to the engine. Okay. Okay. So because of the when this train start moving from particular station, it gives a backward drag along this direction. Okay, because of the friction, or you can say, okay, and this tends to move the train in opposite direction, and it move forward, and it okay, and it is the case of when the wheel start moving. Okay, now when does suppose this is a train in moving position, moving um, situation. Now, if the train give a sudden brake, what will happen? It will give a drag in this direction. Okay, and because of that, this rail part moves, trying to move in forward direction. Fine. That means at the time of starting, that means when it gives accelerating, and when it try to stop, that means when it's slowing down. There is a chance of creep. Got it? When a train is starting or accelerating, the backward thrust on the engine and driving wheel tends to push the rails backward. When it's slowing down or coming to stop, the braking effect tends to push the rail in forward direction. Okay, these things already we have discussed. Next, expansion or contraction joints of rails due to temperature. You also know temperature have a effect of on the railway line. Okay, that's why expansion gap is provided, right? So I already told you, suppose this is your rail part. Suppose this is your rail part and this is your another rail part. Okay, you find out what is the proper expansion gap is provided. Okay, as per IS code, you just find out. Okay, I'm giving you a word. Find out Indian standard range or Indian standard amount of the expansion joint given in the railway track based on different gauges. Okay, IS you can find out by in IS code. So anyway, so there's a expansion joint must be provided. Why? Because of the temperature effect on the component of the rail. Okay, so it may get expanded or it may get shrinked. Okay, so if expansion joint is not provided properly, what will happen? Suppose because of the expansion, it will try to move, it will try to close this to the rail, and it there's a failure may occur along this direction. Okay, and due to this you can say creep will occur. Fine. So there is a even due to the temperature variation, creep may occur. So creep also occur due to a variation in temperature. Creep in this case is influenced by the range in temperature variation, location of track, whether exposed to surrounding or not. Okay. Next, unbalanced traffic. Unbalanced traffic means it depends on the traffic volume also. Suppose there is a railway line, two railway line. One is this one, another one is this one. Okay. Now suppose in a day, 10 rail moves in this direction. Okay, for this rail, suppose this rail number A, this is your rail number A, and suppose this is your rail number B. And suppose only two rail move in along this rail B. Now, what you can conclude from this that possible or chances of creep will be a maximum in this rail only. You know this thing, right? Because the moment of rail is maximum or is more comparative to this rail. That means it's also depend on the traffic. That traffic means how many rails move in a day along a traffic, along a railway track. Okay. So in a single line system, if heavy equal traffic both direction both in number and load runs in both direction, the creep is almost balanced. Okay. That means suppose you are considering there is a one track only along a single track. Suppose 10 numbers of train is moving in this direction and the same almost same suppose 10 numbers of train is moving in opposite direction only. That means the creep may occur in this direction may be neutralized by the creep occur by this direction. They will not move in any either direction, they will be there only because the same amount of load maybe say is acting in all both direction. Okay, so that means in a single line system, if heavy equal traffic both in number and load runs in both direction, the creep is almost balanced. But it is not the it is only theoretical part because it is not the practical one. Okay, there's always a creep because of the uneven load. You cannot say the same number of uh, even the number of the train will be same, but you cannot say that load given by this all the train will be same. Okay, so it is a kind of theoretical one. Okay, the creep is almost balanced in this case. Otherwise, the heavy traffic in one direction will cause creep, which is partly balanced by light traffic in opposite direction. Okay, that means if traffic is light, the creep will be minimum. In double line system, the train on a particular line being unidirectional, creep occur in both the line. Okay, double line system means there is an individual line for both direction. Okay, that means there is a possibility of creep. Okay, these all are causes of creep. So we have discussed about wave action. Okay, wave action. Then we have discussed about क्या क्या था? Yeah. So we have discussed about wave action of creep. Then percussion theory, which is come in joint part only. Then drag and theory, which is kind of similar to the wave action, which is mainly deal with the driving wheels of locomotive, which experience a drag due to the um, your numbers of apartment or compartment, sorry, or wagon connected to the particular locomotive. Then we have discussed about creep due to sudden starting, sudden stopping of the train, then expansion, improper expansion, or the effect of temperature, or due to that, it's also depend on the traffic volume. Okay. Fine. So these all are causes of creep. Okay, now if I say the effect of creep, these things we already discussed anyway. We can discuss here also again. Okay, I think this is too much for this class. Okay, it is almost time. So we do one thing. We stop here about creep. We're going to continue the same class in next class. Okay, we're going to continue about creep. That is, till now we have discussed about what is creep and what is the effect of creep. Okay, that means what is the causes of creep. In next class, we're going to discuss about what is the effect of creep and how to remove creep. Fine. So till now, is there any doubt? I'm going to close this. Anyone? Have you got the idea about what is creep at least?
Yes, sir.
Okay. So you can also go through your textbook, reference book, or you can also search in web, find out about creep. Okay. It's good for you also. Okay. So in this class we have discussed about what is creep, why creep occur. Fine. And somehow you have also idea about how to identify creep in even in when going in the actual field in the regular track. Okay. So in coming classes, in the next class, we're going to discuss about effect of creep and how to that one thing, how to that one remove creep. Okay. I'm going to share the recording in your WhatsApp group. Even the whole the notes of the creep that related to the creep. Even here in the particular creep, that particular notes also you will get the idea about uh, the effect of creep and how to remove the creep. Okay, from reading also you can find out. Okay, so I'll just show you a simple idea about how to remove creep. Okay, so you can see this drawing. Creep, how to here what's they are doing. Even in drawing, what's they are doing. You can see. Suppose this particular this train is moving this in this direction. Okay, can you see? Or I have to share. I have to share, na? Or can you see? My screen is visible or not? No, na?
Sir.
Okay, sorry. I haven't shared. Okay, now can you see? Now here you can see a person is what is doing? He's pulling back the rail with uh, a particular machine or apparatus you can say. Okay. So fixing or connecting with this rail, with this apparatus, and losing all the fastener from the rail, the particular rail which you are going to move. Suppose this rail is moving in this direction. Suppose this movement of the rail is in direction. Okay. So by pulling this rail, we can remove the creep. Okay. There is a way of removing creep. Okay. So this there are some way of removing creep. You can also go through by the notes. Correct. Anyway, I'm closing this now. I'm stopping my recording also. After that, I will take your attendance. Right?